So today's April 2nd, and I'm gonna do another LeetCode daily challenge. I'm still kind of sick, so maybe just try to do this one quick if I can. Oh, shit. uh, so I guess it's the same problem as yesterday, except the constraints, right? Uh, Obviously n cubed is not gonna work. Um, hmm. So let me see. Yesterday I just did the O of n cubed solution. Maybe I should have took some time to upsolve it, but I did not. What I can see though is if we have an array and we move left to right, we could treat everything as like k. And, huh. Actually, maybe we could treat everything like we could loop through j, where everything to the right of it we can have we could hold the greatest thing, right? Because we want nums at k to be super big. And then everything to the left of j we want to be big as well, right? Um, yeah, so I think this whole problem kind of depends on this j. What I mean by that is that we can find everything to the right of an index, the max to the right of an index. And how do we do that? Um, well, we can go from the back, and we could start from the right and then move to the left and then just say what's the max we've seen. So at this one, the max we've seen was 7. At this index, the max we've seen was 7. At this, the max we've seen was 7 and 7 and then 12, right? Um, and then I guess we could also, so that's going this way. And then I guess we could also go this way just for the I, right? Because we want I to be max as well. So that would be 12, 12, 12, 12, and 12. And then if we start J, I guess it's very important that we start J here and we end J over here, right? Because it can never be these. So here's our pool. If we do 6, then it would be we take them, if we take the first index, we're doing this, right? We're doing 12 minus 6 times 7. Okay, and then I think that's how we would solve this. And then if we do this 0, 1, 2 index, then we would do this, which is 12 minus 1 times 7. And then last but not least, if we were at the 2 in or the 0, 1, 2 third index, oh sorry, 0, 1, 2, third index, we would choose 0, 1, 2, 3. Okay, we would choose this, which is 12 minus 2 times 7. And then our answer would just be the max of that. Okay. Okay, so to start off, we just have max right be an array of size n, right? Where n is the length of nums times n. I guess max right at n minus 1, like the very last element, which I guess could just be this, right? The very last element should be the very last element here. Then we just do for I in range n minus 2 minus 1 minus 1. So start what I'm saying is we just start at this index because we already filled the last one here. So let's just start at this one, which is the n minus 2. And then cur max is equal to nums at -1. And then we could just set max right to be the cur max like this. Okay, so then we say max right at I is equal to the max of the cur max or nums at I. And we just keep working down. Yeah, that sounds good. So that is processing like potential like case, right? I don't know if that makes sense, but that's processing the potential case. We're going this way. We want to find the max going max left means whatever index we are, what is the max to the left of it? And that is gonna have a similar style. Cur max is nums at 0. Max left at 0 is the cur max. So we're processing potential i's for I in range 1 to n. The max left at I is the max of the cur max or nums at I. Okay. What I forgot to do is update cur max. So I could just do cur max is the max of itself or nums I. And then this is just going to be the cur max. Similarly, we could do this, except instead of max right, it's max left this time, right? Okay, so now that we processed both of those, we need to start a loop from index 1 to n minus 2, right? Because this is n minus 1 and this is n minus 2. So we could do for I in range 1 to n minus 1, which means n minus 2 is going to be the last thing. What is our... So I get the max value is 0. And then later we could just return the max value. So, I mean, we just need to use these arrays that we did, right? And we just follow this pattern. So let's just have the current value be, what is the equation? Nums at I, which is the max left at I minus max, minus nums at j, which is just literally nums at j, right? Because there's no other choice. We're processing the current index. And then we multiply that by nums at k, which is the max right at k, which is I. Sorry, and then this is nums I. Everything is indexed I right now. Sorry for the confusion, but this is like I, this is like j, and this is like the k. Okay, so that's the current value. And then all we have to do is just say max val is equal to the max of itself or the current value. And then that should be it. Okay, that worked. So I'm going to submit. Uh-oh. Oh, I see. Okay. I kind of messed up with this current max. I mean, the max left and max right. It shouldn't include the current, right? So let me try to think. I just need to make that change. I think that means we just set the max right to cur max first before updating cur max. I think that's what it means. I haven't thought much into this. Let me use this test case. Okay, that worked. Let's submit. Okay, cool. What was the issue there? Well, um, let me see. I mean, it's kind of hard to explain, but I was including this. So like, okay, maybe I could actually draw this. What happened was that if we had an example like 10, 13, 6, and 2, and then I did like, let's just say the max to the right and max left. So max right would be 2, 6, 13, 13. This is actually bad, right? Because um, later, if like, let's just say if j is on this index, we see that we're gonna do like 10 minus 13 times 13, which is just doesn't really make sense. We want everything strictly to the right to be our k, right? That's that was in the instructions. I is less than j, less than k. So we have to make sure that at any index that we choose, we have to make sure that our greatest number, if we were on this index, we have to make sure our greatest number exists strictly to the right. Or our smallest to the left is strictly to the left. But yeah, there are a couple problems that deal with like keeping track of the current max and current min. You could probably find those if you're having trouble with this type of problem. But yeah, what is this like? I think it's linear, right? O of n, because I'm only looping linear. Yeah, O of n, but I am holding O of n space as well. So that's just something to note. O of n time O of n space. So yeah, I guess I was forced to upsolve this one. Hope you guys enjoyed the video, and thanks for watching.